Data types in Pig. Pig supports two types of data, that is scalar data and complex data. Under scalar data, we will be dealing with the atomic data. All the primitive data types like string, int, float, long, double, then character array, byte array, they are included under the scalar data. The value of each cell in a field or column is atomic data type, that is shown in the figure. For fields, positional indexes are generated by the system automatically and also known as positional notation. The positional notation is represented by the symbol $, as it starts from $0 and grows $1, $2, and so on. The first field, that is serial number, refers to $0, and bands refers to $1, and $2 is represented by $2 represents members, and origin represents $3, and so on. So it grows as the number of fields in the table. Under complex data types, there are tuple, bag, and map. So what do you mean by tuple? So tuple is nothing but a record. It's a record of a table. So tuple is an ordered set of fields which contain different data types for each field. The elements inside the tuple does not necessarily need to have a schema attached to it. Tuple is usually represented by a pair of parenthesis symbol. For example, the first record, for first field serial number, second bands, third members, then fourth origin. So there are 4 fields and this constitutes one record. So that is nothing but the tuple. Since the tuples are ordered, we can access fields in each tuple using indexes of fields. Example, $1 from above tuple will return a value Linkin Park. Then $2 it will return 7. Then $3 will return the first value, that is California, and so on. Then bag, what do you mean by bag? So bag is a collection of set of tuples, and these tuples are subset of rows or entire rows of a table. A bag can contain duplicate tuples, and it is not mandatory that they need to be unique. Bag has flexible schema, that is, the tuples within the bag can have different number of fields. And bag is represented by flower symbol, a pair of flower brackets. Bag can also have tuples with different data types. For example, Linkin Park 7 and California, then Metallica, 8, then Megadeth, Los Angeles. So this is an example for bag, which is containing more than one tuples, and the tuples may not be of same schema type. The size may vary depending on the data that it contains. Then the next data type is map. In map, key value pair is used to represent the data elements. The key must be character and should be unique so that it can be indexed, and value can be of any data type. So maps are represented by the symbol square bracket, a pair of opening and closing square bracket, and each key value are separated by the hash symbol. See an example. This is an example. Then we can see different operations in Pig like load, store, and dump. Load function is used to load the data either from local file system or Hadoop. The syntax for load is load path of data, then using function, then as schema. For example, the last line, that is a equal to load, then that is a path name within the single quotes, home, comma, acad lid, acad gid, then pig, employees details .txt. This shows the path of the data where that employees details .txt file is stored, then using, then pig store, then as shows the schema, as followed by id, then its data type, name, then data type, and so on. Path of the data is the file or directory name in single quotes, and using is the keyword. Then function, if you choose to omit it, default load function pig store is used, so it's an optional. So as is the keyword, so which is used to store the schema, which schema is to be loaded. So here that example was shown, so that I just now explained. So this is a way for loading the file from the position or the path where it is stored. Then store is another function. It stores and saves the data into the file system. Syntax is store, then alias, into, then directory where you want to store, then using function. Where store is a keyword, alias is the relation which you want to store, then into is the keyword, then directory is name of the directory where you want to store the relation, then dump or display the results to the screen. The general syntax is dump alias. It's a dump relation or dump schema. Dump alias where alias equal to name of the function. Then a equal to another example which we have already told about how to load, and let us see one more example. A equal to load students as, then schema. So here this will load the file students with the schema, name, age, and GPA. Then dump A. A is dumped. Now A is a file. A holds the file, that is student. Then John 18 4.0f, that is a data content, or you can say it is a tuple. B equal to filter A by name matches A. So this filter function is used to choose the required fields which matches with J followed by many characters. It can be John, or it can be Joy, or it can be Jill. So the starting name should be J. So all the records which starts with J are selected by using the filter class with the condition. Okay. Then interactive shell. So this grunt filter, so this filter, then sort, then group by, order by, join, limit, etc. are the other interactive functions used in the shell. So this grunt and filter, then limit are extra. Other things like sort, group by, order by, join, inner join, outer join, we have seen in SQL. They work similar like the SQL query languages. Then what do you mean by grunt? Grunt. After invoking the grunt shell, you can run your pig script in the shell. In the previous figure, we have shown that the input is taken from the pig script and it is passed on to the grunt shell, then to the parser, then to the optimizer, then compilation, then map reduce, and then on to the HDFS. After invoking the grunt shell, you can run your own pig scripts in the shell. In addition to that, there are certain useful shells and utility commands provided by the grunt shell. The shell commands like sh command, we can invoke any shell command from the grunt shell. The syntax is grunt, then sh, then shell command parameters. Then fs is another grunt command. Using fs command, we can invoke any fs shell command from the grunt shell. The syntax is grunt, then fs minus ls. This is for listing the files. Then utility commands, help. The help command gives you a list of pig commands or pig properties. Then history command. This command displays a list of statements executed, used so far since the grunt shell is invoked. Then filter. Pig allows you to remove unwanted records based on a condition, or you can say that it is a command for selection of required records by putting a condition. The filter function is similar to the where clause in the SQL. Filter operator in pig is used to remove unwanted records from the data file. The syntax of filter is already seen priorly. So this is one more example that is showing the selection of records. Then order. Order sorts a relation based on a single or multiple fields. The order by operator is just like the order by clause of SQL. So it is used to replace the contents of a relation in a sorted order based on one or more fields. So this is an example which shows whether you want to order by in ascending or descending order. Alias equal to order, then which relation you want to order, then by selection of field names, then order ascending or descending. So alias is nothing but the relation which you want to put for ordering. So this is a syntax. Now we'll see an example. We will sort the relation A based on the rating fields and get top 3 employees details with the highest rating. So there is one variable that is sorted equal to, which is used to hold the, now sorted is acting as a bag, you can say. There can be result of more than one tuples. So sorted equal to order A by ratings in descending order. So result equal to limit sorted 3. So this will limit how many records you would like to withdraw. So top 3, only 3 records with the highest rating will be in the descending order will be selected. Then group. This group by clause is also same like the SQL. It groups the data based on one or multiple fields. It groups together tuples that have the same group key. So the example is alias equal to group alias, group again relation, then all or by the field. So you can see the last example. We'll group our relation A based on a rating. So group equal to group A by ratings, then multi groups equal to group A by rating and set. Here more than one field. In earlier case, it was only on single field. Second one is on multi fields. That are 2 fields are considered are passed as the arguments. Then for each class. So for each class or for each function, it generates data transformations based on the desired column of each data. Then alias equal to for each alias generate expression or the field. So you can see the last example. In previous example, we saw how to group a relation based on that rating or salary. Now using for each, we will generate the count of employees belonging to a particular group. Again hold the result group of resulting tuples under result. For each grouped, then generate group, then count A on ratings or A dot ratings. So this will group the information based on the desired column. So you can say it is like a projection over one field, required field. Then limit is used to limit the number of outputs to the desired number. Example is alias equal to limit alias n. We have seen this in previous example also. Then another is a split function. This is used to partition a relation into two or more relations. The syntax is split the relation name into alias if expression, then alias if expression, and so on. So based on the condition, you can go for splitting or grouping of more than one relations from a given relation. So we'll see, these are the examples given. And then we'll see one more example, that is Pig Latin example. So consider a file named population CSV which contains the following age records as population.csv. Now suppose we want to pull out all the result for 50-year-old woman. Then first load the data using Pig Latin. So this is a command, that is population equal to load the file name, then using Pigstore. The next we need to add column names and assign data types, since all of our states are integers and we will just use the int data type. So that is after as, you can see as, year int, age int, then gender int, then population size is also int. Now we need to do it, filter our result where age is equal to 50 and gender is equal to 2. So hold the value in another data type. Filter population by age equal to 50, that is double equal to is equal to 50, and gender is equal to 2. Now this is a result showing the female with age as 50, those many records. Then in addition to built-in functions which you have seen just now, Apache Pig provides an extensive support for user-defined functions as well. Using these user-defined functions, we can define our own functions and use them. The UDF support is provided in 6 programming languages, namely all these things. For writing user-defined functions, complete support is provided in Java and limited support is provided in all the remaining languages. Using Java, you can write UDF involving all parts of processing like store, load, and column transformation and aggregate functions. Since Apache Pig has been written in Java, the UDF written using Java language work efficiently compared to other languages. So types of user-defined functions in Java: filter function, eval function, and algebraic function. Filter function is similar. Then eval function is used in for each clause or for each function. Then algebraic functions act on inner bags in a for each generate statement. These functions are used to perform full map reduce operations on inner bag. So this will wind up. This is regarding the pig. So you can refer Seema Acharya for further things. So all the units are covered here. All the contents are covered here. For extra, the big data analytics by Seema Acharya can be referred. Ready.